Hello and welcome to the Web Basics. Let's look at the topic that you're going to learn in this section. Well, after completing this section, you will be able to understand terms like protocol, HTTP, Internet, TCP/IP, and DNS, and many more of it. This is like understanding the simple definitions of it and understand how these things work together. What is the purpose of a protocol? Why HTTP protocol was introduced? What is Internet? What is the role of TCP/IP, and how DNS works, right? We're going to see what are the DNS providers that is available in the market. Then we'll look at all the web hosting providers as well. Well, we're going to meet them by visiting their website and understand what are the offerings they provide in terms of DNS and the web hosting. You'll understand simple things like client server technology, how actually a website works, and type of the web servers that is available in the market. So we're going to look into web basics as a whole to understand how these things work together, starting from the definitions of simple terms like protocol, HTTP, going on to the architecture level, looking at client server technology, and understand how a website works and what type of components available in the website. Then we'll look at different languages we have, like programming versus scripting versus markup. So we'll understand what are the differences and why they are termed as programming, scripting, and markup. Okay, then we'll look at what is the difference between a compiler and interpreter. We'll take a real-time example of programming languages and execute it to see what is the difference between compiler versus an interpreter. But it will be really an interesting session if you have hearing some of the terms for the first time, and if there are things that you haven't heard before or you're not very clear about, well, this section will help you to clear off all these doubts that you have. Okay, so let's move on to this section now. Hello and welcome to the Web Basics. Let's look at what is the communication challenge gap that we have. Okay, let's understand a challenge that we have in terms of communication and how this web actually help us to solve that challenge. So before that, let's understand what is the challenge. So let's meet two friends. One is Jim, and Jim is from USA, and one is Bob, he's from Australia. Okay, and Jim is thinking about something. So Jim is thinking, I want to buy a phone for a cheaper price. Okay, and he's looking for a phone in the market, and he's always thinking, how can I buy a cheaper price iPhone maybe, right? And Bob is in Australia. He want to sell a phone for a cheaper price. Well, there are two different kinds of people. One is called as buyer, who want to buy things, and one is called as seller, who want to sell things, right? And what is the challenge that they have? They have this communication gap. The gap between buyer and seller. Buyer want to buy it and seller want to sell it. Well, how they can find themselves and how the communication gap can be reduced. This is the challenge here. That's basically the communication gap between a buyer and a seller. Okay, let's understand two challenges that we have. Well, challenge number one is the language. Does Jim and Bob speak same language? That's the first challenge. The second language is a distance. How Jim can find Bob? Well, to solve this communication challenge, you have to solve these two problems. The first problem is, does Jim and Bob speak same language? So you have to agree on to one language, and then you also have to solve a distance problem where Jim and Bob can communicate with each other irrespective of their distance. So let's take this challenge and understand this, and let's understand what are the definitions of protocol, TCP/IP, Internet in terms of solving these two challenges. The challenge number one is the language, where does Jim and Bob speak same language? The challenge 2 is a distance, how Jim can find Bob. Okay, so that's the challenge of communication gap. Let's understand the other things. Welcome to the lecture. Let's understand what is protocol. Let's do a quick review of what challenges we are solving it here. So we have seen up the communication gap between Jim and the Bob, wherein Jim is a buyer, Bob is a seller. Jim want to buy a phone and Bob want to sell the phone. The two challenges is challenge 1 is the language challenge, where Jim and Bob speak same language. The challenge 2 is the distance, how Jim can find Bob. Okay, so let's move on. Okay, so this is the challenge. Let's see how we'll solve this challenge. So let's understand what is protocol. Okay, so Jim staying in USA and Bob staying in Australia, they might be speaking different languages. Okay, so the first thing they have to have is the agreement of the language. If they want to communicate, they have to say, okay, let's speak a similar language. Okay, so that we can have an agreement of a language first, so that we can speak, right? And that is nothing but a set of rules. Well, language is nothing but a set of rules, right? Language defines of what alphabets to use, how you pronounce them, and what words do you use, right? So these are basically the rules of a language. So in terms of protocol, protocol is nothing but set of rules. Okay, when two people communicate each other, they just typically agree onto a language. So if they speak the same language, then the communication can happen, right? In terms of a protocol, protocol is nothing but set of rules. Well, if Jim and Bob want to communicate with each other, the Jim says, let's speak in English. Then Bob says, all right, let's talk. So the communication gap has been removed. That is the first level of communication called as language communication, right? They agree onto a protocol, and protocol define what rules to use for that communication. Okay, so understand this concept of a protocol. When someone say what is protocol, it is nothing but set of rules, right? It is a rule using which you establishing the communication. In between the two people, we agree onto a language, could be an English language, right? And once we agree onto the language, then the communication can happen. Well, that solves the first problem. Does Jim and Bob speak same language, right? When they agree onto a similar protocol, so there has to be an agreement of protocol first. When two people want to communicate, there has to be an agreement of protocol so that these two people can communicate. Okay, so let's move and understand how these things happen in terms of computers. Well, how to system communicate? Even for a system to communicate, they have to follow a protocol, so that when a system communicate with each other, they first define what is the rules we're going to use to communicate. That is the first transaction that happens between the two systems. That is nothing but they follow a same protocol. They agree onto a protocol first before the communication can happen. Okay, so let's take an example. So think of an example of a TV via your remote. Your remote is trying to control your TV. How do you think your TV remote can talk to your TV? That's basically an agreement of protocol called as infrared protocol. This is the protocol that is programmed in the TV remote and also in the TV so that they communicate via this protocol. Take another example of your phone via your Wi-Fi devices. You use nothing but a Wi-Fi protocol. So there is an agreement of protocol wherein your phone basically can talk to a Wi-Fi device. And also if it's a headphone, can you guess what is the protocol that we use to connect your headphone to your phone? Well, that's right, that is your Bluetooth protocol. So you see, for every devices to connect, irrespective of mobile devices or any of the hardware devices, there has to be an agreement first. So remember this, there is an agreement always happening between your devices before the actual communication can happen, before the actual data transfer happens. So they agree onto the same protocol. Okay, same set of rules, agreement of a same language. So now when Jim uses his PC to communicate with the Bob PC, okay, they use a protocol called as TCP/IP. We're going to deep dive into TCP/IP protocol in the next lecture, but on a very high level, we say that when two PC communicate, they have to agree onto a protocol. Okay, and if two PC want to transfer data, they agree onto a protocol called as TCP/IP. TCP/IP is a protocol using which we can transfer information between computers, and obviously you know the information between computers is zeros and ones. So all the zeros and ones that has to be transferred over between two computers is happening via this TCP/IP protocol. We're going to deep dive into what is this protocol all about in the next lecture, but on a very high level, understand this now. When Jim computer want to talk to Bob computer, they use something called as TCP/IP protocol. Now how this communication typically happens, right? The first thing that happens is Jim send a request. That's where the data transfer of TCP/IP happens. Someone has to initiate the request. So Jim PC basically send a request to Bob PC saying that, hey, I want to buy an iPhone. Then Bob PC can respond saying that, okay, this is my response and I'm interested to sell my phone to you. Okay, so that's basically the communication that is happening between the two PCs, and that's how the challenge that we have seen previously, how Jim can buy a phone and Bob can sell a phone, challenge can be solved via this communication. Okay, so let's understand what is a protocol. So what is protocol? Protocol is nothing but set of rules. Remember this definition forever. Okay, if someone asks you what is a protocol, think it as a set of rules, some rules that is being defined already in that protocol. So protocol is nothing but a set of rules that defines how to communication can happen between the two devices. As I told you, two devices has to agree on to the protocol first, then the communication can happen. Every machine is programmed with a protocol, that is nothing but the rules to communicate. If two computers are talking, if two hardware is talking, if a machinery is talking to another machinery, there is something called as protocol already been defined. Okay, the protocol is something like an handshake. They first say, okay, let's start communicating, and this is the language I'm going to use. Then the other person agrees to that language, then the communication happens. Okay, so devices agree on a common protocol before they communicate. This is a very important line that you have to remember always when you think of communication between the two devices. Any two devices in the world that you take in, they first agree on to a protocol. Once they agree on to a protocol, then they start communicating on that protocol. And what is a protocol? Protocol is a set of rules. Well, here is some of the examples we have seen previously. Protocol is a set of rules to communicate. Your phone can talk to your Wi-Fi devices using a Wi-Fi protocol. Computer can talk to a server, download files, upload files via an FTP protocol. You are sending emails, then obviously it is basically an email protocol. Well, that basically solves the first challenge, that is the language challenge. And the language challenge is solved via the protocol. So they first agree on to a protocol. So in terms of Jim computer and the Bob computer, they agree on to a protocol called as TCP/IP protocol. And Jim initiate the request to say, I want to buy a phone. The Bob send a response to Jim saying that, okay, I'm going to sell the phone to you. Well, so challenge 1, that is the language challenge, does Jim and Bob speak same language, is solved via agreeing on to a protocol. Okay, and what is a protocol? Protocol is a set of rules. So let's look at the challenge number 2, that is the distance. How Jim computer can find Bob computer. Okay, so let's understand this definition by understanding what is internet. All right, so let's jump in another lecture, understand what is internet. Hello and welcome to the lecture. Let's understand what is internet. So let's look at the problem that we are solving it here. We have solved the first challenge, that is the language challenge, how Jim and Bob can speak the same language. We have solved it. Now Jim and Bob agree on to the same language and then they communicate. So let's understand the language number 2, that is the distance problem, right? How Jim computer can find Bob computer. And in terms of understanding how they solve this problem, we'll understand what is internet as well. So let's look at this example of transfer of information via the computers. We said that we will use TCP/IP protocol. TCP/IP protocol is basically helps you to transfer information from one computer to another computer. Okay, let's take an example of your TV remote via a TV, where we agree on to a protocol saying that infrared protocol is used to communicate between your TV remote and your TV. So that's not a problem. So communication can happen. You can control your TV with your remote. But the problem is there is no distance problem between your TV remote and your TV. Okay, obviously we know if you take your remote and go out of your house and try to control your TV, it will not happen because your distance is a problem, right? That's where the challenge that we are trying to solve it here. When there's a distance, how they find each other, right? How they try to communicate when there is a distance. Well, if there is no distance, then there's no problem. Like if you stay in your home, your Wi-Fi is not a problem. If your headphone is nearby you, then that's not a problem. If you move away from your headphone to your phone, then the distance challenge come in picture. Language is not a problem, because once the distance is not a problem, language is not a problem. Language has been agreed, but when the distance come in picture, then that's where the challenge that you have to solve. Okay, so let's understand if distance is a problem, how do you solve that challenge of communication? And in terms of Jim and Bob, okay, Jim stays in USA and Bob stays in Australia. Obviously distance is a problem here. And how Jim computer can talk to Bob computer when they live in two different regions so far away. Okay, so let's understand how this problem can be solved. So let's understand what is internet. Okay, internet is a network. Okay, remember it is a network where group of computers connected together with a single wire. You have all these computers in the internet, they all connected with one wire, irrespective of where they stay. If you are connected to an internet, you are actually saying we all are connected via a single wire. And why you have to connect via a single wire? So that you can find each other. Well, think of how the current flows in through your house. Okay, all the current that we flows in through our house is via the power cables, right? all the power cables or the current cables that is connected all over the world, sending all this current back to our house, right? Similarly, in internet, all the computers are connected together via a single wire so that the information can be passed via these computers and they can be reachable via the single wire. Okay, so that's the concept of an internet. So when someone say what is internet, it is nothing but a network, right? It's nothing but a network where all the computers are basically communicated with a single wire, so they can communicate, they can find themselves and they can communicate. Okay, so let's look at what is the purpose of internet. All the computers in internet can find each other and connect. That is the only purpose that internet exists. So let's take a step back. Now let's understand Jim and Bob's problem. Well, Jim's computer is in USA and Bob's computer is in Australia. So with the help of the internet, means if Jim computer can connect to an internet and Bob computer can connect to the internet, then they all are connected via a single wire, and now they can find themselves, because internet is a network where all the computers can be reachable, can be found, right? They can be found, they can be connected, and you can send information between the two systems via the same protocol, that is TCP/IP protocol. Okay, so that's how the internet can solve the problem of the distance. So once Jim can find Bob computer via the internet, then Jim can send a request to say buy phone, and Bob can say send request to sell the phone. That's how the Jim computer can find Bob computer via the internet. So let's look at the definition of an internet. Let's do a quick reference of what we have seen so far. Internet is a network where group of computers connected together with a single wire. Systems connected in the internet network are able to communicate with each other and exchange data. That is the main purpose of internet. You can connect to internet to access other computers and exchange data via TCP/IP protocol. So that's the purpose, right? So if Jim want to find Bob computer, they connect to internet so that they now can be visible and they can connect with other computers that is visible in the internet as well. Well, that's the purpose of internet. So let's understand whether we have really solved the Jim and Bob's problem. Well, we have seen Jim can now connect to internet, Bob can connect to internet, everything is fine. They can find themselves and they can connect themselves. But there's one problem. There are billions of computers in the internet. With billions of computers in the internet, how Jim computer can uniquely identify saying that, oh, this is a Bob computer, let me send a request to buy phone. Okay, internet is a place where you can connect to all the computers, but how do you identify them? How do you identify a specific computer in the internet? That's the challenge, right? How Jim computer can identify Bob computer. Let's understand how this problem can be solved. Okay, and this problem of identifying computers can be solved via this protocol called as TCP/IP protocol. TCP/IP protocol is a protocol used to exchange data. It has some definitions also attached to it. Means you have a set of rules to follow. Once you follow this and you are reachable, then TCP/IP will take care of communicating to a specific computer in the internet. Okay, so let's understand what is TCP/IP and understand how you can solve this challenge, like how Jim computer can identify Bob computer. Okay, so let's look into that in the next lecture. Hello and welcome to the lecture. Let's understand what is TCP/IP protocol. Let's do a quick recap of what challenge we were stopped at in the previous lecture. Well, Jim computer can connect to internet, Bob computer can connect to internet, and they can find themselves. But the challenge in internet, there are billions of computers. So how to uniquely identify the computers? How Jim computers can identify Bob computer? Okay, so let's solve this challenge by understanding the TCP/IP protocol. Let's take an example of internet, right? In internet, we say there are billions of computers. So how can you uniquely identify them? You can uniquely identify them by giving them a unique number, right? Once you give them a number, okay, then you can uniquely identify them using that number, and this number is basically nothing but an IP address. Okay, every computer have a unique address, that is the number in the internet, which is called as IP address. So every computer that connects to the internet gets this unique address. There cannot be duplicate of unique addresses. There has to be unique addresses when you connect to an internet. Even though you are connecting to the internet via your Wi-Fi, you actually get a dynamic IP address in the internet, so that you are identified uniquely in the internet. Okay, So what is IP address stands for? IP stands for Internet Protocol that is used in the internet to communicate between the systems. Once you have an IP address, then you can identify yourself and then the communication can happen. Example could be like a phone number for every SIM. How do you identify a unique phone in the whole world? You have a phone number. And how do you reach to your friends? Like how do you make a call? You call via the phone number. Similarly, in internet, if you want to reach to a computer, you reach via the unique address that is nothing but the IP address. So that solves the challenge of identifying a computer in an internet by assigning each computer an unique address. Let's understand what are the details of its unique address, and this address is called as IP address. So once the IP address is assigned to each of the computers in the internet, now using this protocol called as TCP/IP protocol, they can uniquely identify that particular IP address and then they can establish a connection and transfer the data. Okay, that's the rules of a protocol, that you need to have an IP address first, and that IP, using that IP address, this TCP/IP protocol will communicate, establish the communication and transfer the data. Okay, so every computer in internet has a unique IP address, and TCP/IP is a protocol used to connect and communicate. Remember these definitions of what is IP address, what is a TCP/IP, what is the purpose of TCP/IP, and how IP addresses are assigned to the computers, and why you need to have a unique IP address in the internet is just to find themselves and establish a communication. Okay, so let's understand how the IP address looks like. So IP address is basically unique addresses which is separated with something called as dot. So if you look at here an example, 192.87.45.20, this is a number that is assigned to a computer in the internet, and this is how you represent an IP address. Let's look at an example of what is an IP address. So I have opened up a command prompt. Okay, so how to find my IP address? Okay, you can go to ipconfig. Once you click on ipconfig, you will see something called as IP address. An IP address is separated with a dot. Okay, and it has 3 numbers in it. Okay, that's how a IP address is been assigned to a computer, and this is a dynamic number. Whenever I log off from the internet and log in again into the internet, maybe this number will change. Okay, and every computer in the internet has something called as IP address. Okay, and if you have to find an IP address of yahoo.com, you can say www.yahoo.com. okay, you will find the IP address here. Okay, we'll understand what is this and what is this. This we know is an IP address. This is called as host name. So in the next section of what is DNS, we'll understand what is this and how this thing work. But for now, focus on what is the IP address. This is the address using which I can use the yahoo.com server. If you want to ping the google.com, okay, you can find an IP address. However, this will be dynamic for Google because they have many servers, right? So you might be reaching to a different server every time you do a ping. Okay, that's a different concept altogether, but remember for now that every computer in the internet can be found via this something called as IP address, and it looks like this. You have 3 integers dot, then 3 integers dot, 3 integers dot, 3 integers. Okay, so that's how the IP address is used to identify a computer in the internet. So now that you know what is an IP address and how it look like, let's do a quick recap of what is TCP/IP. TCP stands for Transmission Control Protocol and is used to connect and transfer data. Remember this definition of TCP/IP. The purpose of TCP/IP is basically to connect and transfer the data. To connect, it has to find out what is the IP address first. So in order TCP/IP to work, it should know what is the IP address. And IP stands for Internet Protocol, using which any computer can be identified with a unique IP address. We have seen yahoo.com, google.com. By just doing a simple ping or using a command called ipconfig, you can find your own computer IP address. When you are connected your PC to an internet, you will definitely have a unique IP address, and that is nothing but the Internet Protocol. And now you can connect to internet to access other computers and exchange data via the TCP/IP protocol. So how you can access Google, how you can access Yahoo, all these computers that is Google is hosting or Yahoo is hosting can be reachable via the IP address. Alright, so let's go back to Jim and Bob's problem. So now Jim computer can identify Bob computer via a unique IP address. If you look at the diagram here, every computer that is in the internet have a unique IP address, and then the TCP/IP protocol now can work. The transfer of data can work, and each computer can identify itself with a unique number. So the problem of Jim computer identifying the Bob computer is really solved by using the IP address. Okay, with the IP address, everyone can reach to any computer that they want. It's similarly to your phone numbers. You can reach to any phone by dialing that phone number. So there's one more challenge attached to this. Well, however, there is one challenge attached to this. Let's understand what is that challenge. Well, it is hard to remember billions of IP addresses. You see, the IP addresses is so funny. Well, IP addresses are hard to remember because these are integers. And if you have billions of computer, you really cannot remember these numbers. And if it is dynamic, let's say you're connecting to internet and then you're logging off, again connecting, then you get a dynamic number. So it's again not a static number, right? It might be dynamic number, or it could be a number that is very hard to remember. So the challenge is, how do you remember these numbers? This number can be remembered via a DNS name, that is the domain name service. Think of how do you store a phone number in your phone, right? There is a phone number, and then in the context you add the name to it. That name is nothing but domain name. Let's understand domain name in the next lecture. Welcome to the lecture to understand what is DNS, that is domain name service. Let's look at what challenge we're going to solving it here with the DNS. We said that every computer in the internet have a unique IP address, and this is how the IP address looks like, but it's hard to remember billions of IP addresses, right? So how do you solve that challenge? So let's understand that. Well, that can be solved via something called as DNS. Okay, every computer in the internet which has an IP address, you can give an English name that is easy to remember name. That is nothing but domain name service, DNS. Okay, DNS is nothing but an English name or an easy to remember name for your computer which has an IP address. Remember, you need to have an unique IP address, and to that unique IP address you assign the domain name system. And why do you do it? Why I have to give a domain name for an IP address? I can just use the IP address as I want. I don't want to have a domain name. Well, there's no problem, right? You can connect to any computer via the TCP/IP. That is the rule of the protocol. You need to have an IP address. It's not a rule that you should have a DNS name, but you can even connect to any computer via the IP address. That's fine. But imagine a situation wherein you have to remember thousands of phone numbers, right? What you typically do is, you in the contact list you assign a name to a phone number so that you don't have to remember the phone number. And really it is hard to remember numbers, and it's easy to remember name because the numbers are complex and it is difficult to remember. We have something called as domain name system which gives us an English name to our IP address. Okay, so let's take an example. Okay, so we have a computer in the internet having this IP address. We can assign a host name or a domain name. You can even call this domain name or a host name something called as phptraining.com. And once this name is assigned to this IP address, so if you have to find the phptraining.com server, you don't have to remember the IP address now. You only have to say phptraining.com and you will connect to my computer. Okay, so remember, there is a linkage between your IP address and your host name. You have to create this link. First of all, you have to have this domain name purchased. Again, the domain name has to be unique, obviously, right? So you have to have a unique domain names, and each domain name is assigned to a computer's IP address. Well, if you want to have a name for your computer in the internet, you have to buy the domain name. Okay, so let's understand who sell this. So there are two types of providers in the market. One is called as web hosting providers. One is called as domain name providers. The web hosting providers sell space in the server. Typically, web hosting providers have these servers with IP addresses in the internet, and these servers are very, very huge. Okay, they have tons of space available. They have internet attached to it. it is in the internet and can be found with an IP address. So instead of putting our own server in the internet, we go to these web hosting providers and then we buy some space from them. Once you buy the space, you get that IP address and the space from the web hosting providers. Okay, and then you want to assign a domain name, that is the English name for your IP address. You go to something called as domain name providers, who basically sell a domain name, and once you buy the domain name, you have to do a configuration. You have to say this is my domain name and this is my IP address. If someone is trying to access your domain name, that request is sent to the web hosting provider. So remember, there are two types of providers: web hosting providers and domain name providers. Web hosting providers sell space. They have unique IP addresses, so they sell space in their server. Domain name providers sell that English names that you can buy. It has to be unique in the internet and you can attach to that IP address. Okay, so let's look at an example who are providing the web hosting providers and also domain names. Okay, so let's look at the web hosting providers. So HostGator is one of the vendor or the provider in the market who provide web hosting, and they provide web hosting for $2.75 per month, and they have their own plan. Okay, so let's look at different plans that they have. You have dedicated hosting, means you get the full control of the PC. You have dedicated control, full root access and scalable resources. There's some differences in the performances here. Then they have the web hosting for WordPress. You want to install WordPress, they have special softwares to do that. Then they have a simple drag and drop where you don't get very much control on the server, but you get this softwares to create websites. Okay, so let's look at their plan of web hosting. You click on web hosting. So here are their plan. Okay, and many of them, all the plans come up with this unmetered bandwidth, means you have unlimited bandwidth, so you don't run out of the bandwidths of the internet. And what they are saying is single domain, unlimited domain, and unlimited domains means you can point n number of domain names to this one server. For hatchling plan, you can have single domain. For baby plan, you can have unlimited domains, and similarly for business, you can have unlimited. But once you go to business plan, you get this dedicated IP. For hatchling and baby, you will definitely get an IP address, but that is shared with others. Okay, and when you go to business plan, you get this dedicated IP address. Okay, and you'll get the free access certificate and you get many other components of it. The most important thing that you have to understand is they are selling space in the server. They have this server, massive server, and they are selling space in their servers. So you get a space, you get the IP address, some are shared, some are dedicated, and you pay the price to get those details. If you click on technical specs, right, you will see some of the details of that server, and they'll tell you what other offerings they are giving you. Like in terms of programming and database, they give you MySQL installed on that server. You get that cPanel to access, you get email feature, you get all this support and all those tools available. Okay, so they are actually selling you a space on the server with some software installed on it. Okay, similarly you can go to Bluehost. Bluehost also have web hostings. Okay, they have WordPress specially hosting, e-commerce hosting, and they get dedicated hosting as well. Dedicated hosting is one server, they give it to you and you have the full control of that server. And when they talk about server, obviously they talk about cores, space, RAM, bandwidth, IP addresses. They're really talking about computer, right? They're talking about computer which is in the internet and have an public IP addresses. So first thing you have to do is you have to buy a space, right? You have to buy a space, and you have to buy a space in any of the servers. You can start small, like $2 per month, or you can go up to dedicated hosting where dedicated hosting where you get to have your own server, and you can get to choose what kind of server you want and even what OS you want, right? That is the first step. So these are the vendors. One is HostGator, another is Bluehost, and there's DigitalOcean as well. In DigitalOcean, you create something called as droplets. Okay, let's look at what is the droplet. Let's look at Ubuntu. And to create the droplets, they give you a price. Let's say you want one CPU, 25 GB SSD disk, 1 terabyte of transfer, that's the bandwidth, 1 GB of RAM. You have to pay $5 per month. So they'll give you this server, and then you are on your own. You do install whatever you want to install on that server. So these are called as web hosting providers. They provide space in that server. They even provide you server access. They even let you choose what type of servers you want, and then you have to just pay the price. Okay, once you buy the space and the IP address, you need to have an unique English names, right? And where do you buy the English names? You buy that from a domain name provider. And if you go to godaddy.com, so godaddy.com is really very famous for selling domain names. So the first thing, when you go to their homepage, they'll ask you what is the domain name you're searching for. Okay, similarly, if you go to namecheap.com, they will help you find a domain name. Once you purchase a domain name, then you can go inside the configuration to configure a domain name with the IP address. Okay, so let's do a quick check of what is the domain name available or not. Let's say you want to buy yahoo.com, then they'll say yahoo.com is taken, you cannot have it. Okay, so domain names are unique. It's an English name that you're buying. You're not assigning it to a server first, right? You will buy this, and then once you have this server, they'll give an IP address. Then you do the linkage between this server and that server. That's a configuration altogether. But remember, on a high level, there are two different kind of people in the market. One is the web hosting provider, that is the HostGator, Bluehost, DigitalOcean. They are giving you the web server. They are giving you a server with a space in it, and then they have a unique IP address. There are another type of providers who provide you the domain name. They are selling the domain name so that you can assign this domain name to this IP addresses. So it's easy to see you have two different kind of providers in the market. One is really selling the web hosting, another is selling the domain name. So now that we have seen the web hosting providers and domain name providers, let's understand how the DNS works. Okay, so let's take a step back. Let's say Bob has purchased the web hosting, and also he has purchased the domain name, and he has assigned his domain name to his IP address. Well, remember this: when Jim types bob.com, the computer doesn't understand DNS name. The computer only understands IP addresses. The TCP/IP protocol, the rule says you need to have a unique IP address. The rule never talks about DNS. So yeah, there should be a way to convert your host name into an IP address, and that is done via something called as DNS servers. So in the internet, there will be so many DNS servers always syncing each other to tell that this, based on this DNS name, this is the IP address. So once you purchase from godaddy.com, they sync that detail. Like let's say you purchase yahoo.com, and the godaddy.com will sync those details of your DNS server to all the DNS servers in the internet. Okay, so remember, there is a DNS server in the internet which converts your host name, that is the domain name, to the IP address. Once you find the IP address, then that Bob computer can be uniquely identified in the internet. Then the TCP/IP protocol can help to connect and communicate the message to that particular system. Okay, so that's the role of the DNS server. So if you look at the internet as a whole, right, every computer has an IP address, and every computer get to have an DNS name. Okay, and then there are DNS servers sitting in the internet. Whenever someone types the DNS, then that DNS is converted into an IP address first, and then the communication happens on that IP address. In the previous example, when you say ping yahoo.com, ping google.com, the yahoo.com and google.com are nothing but the English names, right? They are DNS names, and conversion of that DNS name into an IP address is done by the DNS server. So remember, in the internet there are DNS servers. The job of the DNS server is to convert the DNS name into an IP address, and once the conversion happens, then it's easy to find those servers in the internet. Alright, so let's do a definition of what is DNS. So DNS stands for domain name system. That's the full form of DNS. Well, DNS name can also be called as host name, and the main purpose is to easy to remember names that is assigned to an IP address of a computer in the internet. Okay, because it is hard to remember IP address, we buy this domain name, we assign the domain name to the IP address, and in the internet the DNS server take care of converting that domain name into an IP address. Okay, so DNS server basically helps to convert host name to IP address. You have to remember this concept. because once you buy the domain name, you need to know there are DNS servers, okay, which actually helps to convert the host names to IP address. And then you have to purchase the domain name, and once you purchase them, you have to do this setting by yourself. No one is going to do this for you because no one knows what is your IP address. So once you buy the domain name, you have to map this IP address to the domain name. Okay, so understand this concept of how DNS work and what are the components of it and what you have to do once you buy the domain name as well. So let's look at the problem that we have seen with Jim and Bob. So now Jim and Bob can identify themselves with the IP address, and also with the DNS. Now Bob can buy an DNS name, that is bob.com, and then he can match this bob.com with the IP address, and Jim can find Bob computer via the bob.com, that is nothing but the DNS name. So now we have solved the challenge of how Jim can really find the Bob computer, but there's one more challenge. Let's look at it. Well, the challenge is you can use TCP/IP protocol to transfer the data, any data, right? But you want to transfer a specific files like the text files, pictures and videos. Then what protocol can help? TCP/IP is basically a transport protocol. What is mean by transport protocol? It's basically doesn't understand what you're transferring. It just transfers zeros and ones, right? It is just the purpose of TCP/IP is to find that computer via the IP address and transfer the data. It doesn't really care what you're transferring, okay? But if you want to take a level up and then say, okay, I just want to transfer files, pictures and videos. These are nothing but the file formats, right? And you want to transfer this from Jim computer to Bob computer, or you want to pull those information from the Bob computer, where protocol can help, okay? That can be done via the HTTP protocol. So let's understand what is HTTP in the next section. Hello and welcome to the lecture. So let's understand what is HTTP. So let's understand what protocol can help to transfer files, pictures and videos, because Bob want to send maybe the image of a phone to the Jim to show that this how his phone looks like, and maybe Jim can fill up a form and then process his payment via transferring his data to the Bob. Okay, so there has to be communication between Jim and Bob via the specific formats, that is basically files, pictures or videos, right? And what protocol use? We can use TCP/IP because TCP/IP is a transport, it's an underlying protocol. The responsibility of TCP/IP is just to transfer the data irrespective of the format. Okay, so let's understand what is the protocol that we'll use. The protocol that we'll use is HTTP protocol, and HTTP stands for Hypertext Transfer Protocol. When I say hypertext, well, hypertext is nothing but your videos, pictures, music files and normal CSV files. These are called as hypertext. So if you want to transfer hypertext between the computers, you have to use a protocol called as Hypertext Transfer Protocol. And HTTP is an application protocol, means it is abstraction. It is one layer on top of TCP/IP protocol, and that is protocol that is used to transfer data like images, video files over the web. So remember, in the web, when two computers can find each other with a unique IP addresses, and then there is a connection between the two computers via the TCP/IP, there's one more protocol built on top of TCP/IP protocol called as HTTP protocol. And using this HTTP protocol, you can transfer these hypertext files. Okay, as I say, hypertext is nothing but the media files like images, videos, files, and you can transfer it via the HTTP. So when we talk about details of HTTP and web, you are more focusing on these kind of data like JSON file, XML file, video file, images file, because this protocol is built in such a way that it is able to handle and transfer this kind of files over the web. And remember that HTTP will depend on TCP/IP protocol to transfer the data. But how the data should be transferred, what kind of data, is basically handled with the HTTP. And obviously it is a protocol, so it has set of rules. How do you make a communication? How do you initiate the communication? What type of request that you have to send? All this been pre-coded into HTTP. So when Jim types bob.com onto the browser, he's basically using something called as HTTP protocol. Okay, and this HTTP protocol is responsible for communicating between the Bob's computer and transferring all the data from Bob's computer to the Jim computer. So let's do a quick definition of what is HTTP. HTTP stands for Hypertext Transfer Protocol. That's the definition of it. Because HTTP purpose is to transfer the hypertext, that's why it's called as Hypertext Transfer Protocol. And HTTP protocol is used to transfer images, videos, files over the web. Obviously, HTTP uses TCP/IP protocol to transfer the data packets between system, and it is built on top of TCP. So that's all about HTTP protocol. Let's understand how HTTP actually works in the internet. So we go details of how HTTP works and we'll understand the details of it. Hello and welcome to POCast.com. I'm really super excited to teach you this section of protocol and HTTP. I think this is the most important topic you should know. And without this knowledge, you cannot be a pro in web. Let me ask you something. Do you know how web works? What protocol does it use? Can you define what is a protocol and how the message is exchanged in web? Do you know HTTP inside out? I don't want to bombard you with the questions or convince you to take this course, but I really believe that without the solid foundation of HTTP, you cannot understand complex concepts out there. And I want my students to talk like a pro and really understand it without leaving anything behind. My promise to you in this course is that after you finish taking this course, you will have a different perspective about how web works. Yes, it is like that moment when Neo finally understands the Matrix in the movie. So, jokes aside, you will learn something serious stuff here and will pick up plenty of jargons and concepts around HTTP. Remember this, everything you do in web, most of the jobs is get done by the HTTP. There is no prerequisite for this course because I'm gonna start from scratch, from ground zero. So let me walk you through what topics I'm gonna talk in this course. We'll first understand what is protocol and what that word protocol actually means. Then we'll correlate that protocol world with the web world. Then I'll explain to you what is HTTP, and then we'll show you how web uses HTTP to exchange the message. Then we understand basic theory behind HTTP, that is request and response. We look at HTTP port and content type. Then we'll understand request methods like get, post, put, etc. Finally, we'll try to understand what are the HTTP responses, what are the different numbers that represents the status codes, and then what is the meaning behind it. The most important thing you will learn are the new jargons, very helpful for future lessons. So please don't skip this lesson. I don't know what level of understanding you have about this course, but I will start from scratch. I will expect it's a ground zero session. I'll assume you are hearing about protocol and HTTP jargons for the first time and trying to understand it. So let me start the course with this understanding. So what is the word protocol actually means? Protocol in general English means agreement, contract, arrangement or deal. So in order to achieve something, we get to an agreement, we agree a deal, or we sign a contract, or we get to an arrangement. That's a real life scenario. In a communication scenario where two people want to communicate, they can make an arrangement, they can make an agreement, they can make a deal, or they can make a contract to talk in a language they both understand. Let's imagine you go to a new country. Then you will make sure you speak in English. Why? Because it is a protocol that you think everyone will understand. Same like body language. It's a protocol that many people will understand. So you use them. You can communicate only when you have protocol or a common understanding with the other person. Means both agree to a protocol. You can even say this, protocol helps to communicate. I'll give you one more definition. An agreement on a common language to communicate can be defined as a protocol. So remember this understanding of protocol. It is a contract to communicate. Let me give you another simple definition. Protocol is nothing but a set of rules to communicate. We can even call this protocol as communication protocol to make sense in the context of communication. Yes, I know. I repeated the same definition in different ways to make sure you can understand it. And I hope you understand the definition of word protocol. If not, then go back and listen again and make sure the definitions stick to your vocabulary. Here onwards, I will use the word protocol, which actually means are some kind of rules used to communicate. That will be my understanding. Next, let's define HTTP with the use of the new word that we just learned, that is protocol. Before we jump into HTTP, I want to bring the context of understanding to system level. We learned protocol as in general, right? Now let me bring you the same definition when two systems want to communicate. If human can communicate via protocol, then why not computers? Yes, computer can use a protocol to communicate. Let's say two systems want to communicate, then they have to agree on a protocol so that when they talk to each other, they understand what they are interpreting. And if the protocol is changed, then they have to re-agree on what is the new protocol that they want to communicate on. Let's take this concept further. If you just look around yourself, we use protocol everywhere. When we connect to our home Wi-Fi, that's a Wi-Fi protocol. When we transfer a file to a server or download a file from a server, we use an FTP protocol. When we send emails, that is transferred via an email protocol. Everything that we do has a protocol, and we cannot change the protocol. Like we cannot send email with an FTP protocol, or we cannot access Wi-Fi with an email protocol. So every protocol has a set of rules, and with that rule you can only do a specific job. You must use the right protocol to communicate with the right device. Means you should talk in the device language in order to communicate with the device. If that device speaks Wi-Fi, then use that Wi-Fi protocol. If that FTP server speaks FTP protocol, then speaks in FTP protocol. That's basically how humans interact, right? If you and me understand a native language, we might be talking in that language. I hope you're getting the idea. The point I'm then trying to make is we use specific protocol to communicate to specific devices. Let me now define what is HTTP with the context I just explained to you. HTTP stands for Hypertext Transport Protocol. So let's look at the definition one by one. What is hypertext? Hypertext in general English means text that is displayed on your computer screen. And transport means the text that is being transferred. Protocol means, I bet you know what protocol is. Well, I repeated it many times. It is a rule to communicate. So let's look at things together. HTTP is nothing but a protocol that is used in the web to transfer that hypertext onto your computer or transfer over between the machines. Let me give you a simple definition. HTTP is a protocol used to communicate in web by machines. So don't assume HTTP can do everything between the two systems. HTTP typically used to transfer text between the machines on the web. So web is a very big word there. Yes, web is a keyword that we need to really understand. Then you can understand what is HTTP stands for. Web generally means it is an interlinked systems or network of networks. You can imagine like large number of systems connected with a one wire, and many systems can exchange information, and also every system connected in that network has a unique name to it. And using the web, using that network of networks, we can access any data that is available in any of the systems. It could be document, images, audio file, video file, any files. So let me again walk you through what is the context here. Web basically means there are large number of computers connected together with a single wire, and then each system has many files in it. So typically what you're trying to do here in the web. So typically you're trying to get some data from the server residing in the web. And what actually helps you to get the data? HTTP is a protocol that helps you to fetch that data from the server in the web. Again, it has the rules that we need to follow, and this course is all about learning those rules. In the next sections, I'm going to teach you what are those rules that HTTP follows to fetch the data from the servers. And all the things that you do with HTTP, you're trying to fetch the data, or you're trying to send some command to the server within that web to do something with the data, because it is an hypertext, right? So let me give you a simple definition to remember. And don't forget this definition, because this definition will explain what is HTTP. HTTP is a protocol used to communicate in web by machines. And now you know what web means. Let me show you where do you generally use HTTP. If you open your browser, and generally you might have typed pocast.com, and before that pocast.com there's something called as protocol, and that protocol you might see https:// we are talking about HTTP, then what that S stands for? Well, S stands for secure, right? And pocast is a secured site. So that HTTPS or HTTP generally indicates what protocol you're using to access the pocast.com website. So pocast.com is a server sitting somewhere in the web, and you're using a browser to access the site. And all the thing that you're trying to do is saying to HTTP, that's our friend, HTTP, can you go and connect to this pocast.com server and fetch the site for me? And that's how the protocol helps us to communicate in the web and exchange the message between your machine and the server in the web. In the web, all the servers are sitting and connected. All the servers hold the hypertext. So all you have to do is to apply the universal law, and that is ask and it is given. Well, HTTP works similar way. You need to ask, or your system need to ask to get that hypertext. And all we use is, one of the example is a browser. You ask via a browser to show something. That's how the request is fulfilled. And in the web of servers, we need to go and keep asking so that the server will keep providing you with the details you ask. And it's not something new, right? We do it every day. You go to Google search engine, you ask, and then whenever you ask, the Google search engine will execute something and fetch the data for you. If you're looking at the diagram, there are two roles. That is a new jargon there. Understand this jargon because I'm going to follow this jargon throughout this course. The role on the left hand side is called requester, and the role on the right hand side is called provider. So requester is something who request, and provider is something who provide. So requester needs to ask the provider, or the requester need to request and the provider has to provide something. Easy to remember this concept, right? Requester will request and provider will respond. Don't forget this diagram and the theory that we just discussed. This is the one of the more important topic or concept behind HTTP. Ask and it is given. If you don't ask, then it's not given. No request means no response. Let's make this definition go one step ahead, and then we correlate with the things we do in our daily life. By now, you should be very clear how HTTP helps to send a request and get the response. Let me bring back another jargon here, that's a client-server technology. In the client-server concept, client is a requester, server is a provider. Client makes a request and server will respond. We do this every day, right? We type the URL in the browser, that is your client. And then once the request is sent over to server, the server will respond back to your client. And what is helping us to communicate between client and server? When you do it over web and you want to access hypertext, it is the HTTP protocol that will help to send your request to the server and receive the response from the server to your client. And thanks to Berners-Lee, the gentleman who has invented this concept and make it available for us. Next, let's look at how HTTP communicate, or what's inside this protocol. So we understand there is some kind of request and response to happen in order for us to communicate in web. And HTTP is our best friend who helps us to do that work for us. Let me show you the demo on how real time this works. Obviously you won't understand everything shown in the demo because we did not learn how HTTP talks and what is its language. But I want to make you understand that there is a request and a response. Let's look at it. So let's look at how HTTP is used to send a request and get a response. So I will visit a site, and now I will press F12. This will bring up the console, and you have to go to the network tab, click on the network tab, and then you will see some information here, right? First thing we'll notice what is a protocol. Okay, so if you look at the URL, you're actually using an HTTPS URL, right? As I told you, S stands for secure, right? So HTTPS is trying to help us to go to this server and trying to fetch all these files for us. Okay, let's look one more time. So HTTP protocol will go and connect to the system, download the files. So all the files that is available on POCast.com server will be downloaded by this client. So this browser is a client, or this browser is a requester, and POCast.com is a provider, or a POCast.com is a server. Okay, so let's look at the POCast.com request. So when you double click this, I just double click this and I see this history. Okay, so let's review this. So let's say I press one more time. You can go to this tab, then you can see different tabs here: header, preview, response, cookies, and timing. Let's look at the headers. So there is a request header and a response header. So we send a request, we get a response. So that is the definition that we have learned in terms of HTTP. So let's look at request. You might not be able to understand everything that is been sent over to the server, but I want to bring you the attention that it's saying I'm talking to you with a HTTP 1.1, means I'm using 1.1 version of HTTP to communicate to you. And where should the request should go? The request should go to POCast.com server. Now let's look at the response. You have to click the view source. The response says, okay, I understand that even I sent you a response with 1.1 version, and it's okay, it's nice. I mean, I acknowledge your request and I am sending you the data. And if it's unable to send the data, maybe you get a separate error, that is a 403 maybe, when you don't have access to the server, right? So this is how the request and response works. Let's look back into other definitions, and then we come back here and again relook into these definitions. In the hands-on, we have seen how the browser sends the request to the server and how the server responds with the HTTP response. I'm just trying to show you what is the structure looks like for an HTTP request and a response. The response or a request will look something like this. It will have a message header, then an empty line, and then it will have a message body. When you're sending a request without any data, then the message body is empty. And well, when a HTTP send a response to you, then the message body has the data. And what details are available in the message header? Let's look into it. Let me explain about the content type. Content type means when a request has been sent from our browser to a server and from server to our browser, we are exchanging some data. Content type is generally a type of the data that has been exchanged between the two servers, right? So in a request header, if you're seeing the screen, the request header generally says I accept this kind of data. Means this client, my browser, is telling to server that I can accept text or an HTML based output. I can accept an HTML and XML based output, and I can accept XML or an image, or actually it accepts everything, right? It's saying I have the capability to accept all these things, and that's basically a content type. So request headers is basically a header sent by my browser to the server stating what I can accept. And when the response is being sent from the server will tell us what is being sent over. So the response use the field called content type, and then it's actually mentioning text.html, which saying I have sent you the HTML files. And HTML is a generic content type, can include CSS, JS, JavaScripts, can include your HTML files, all those things. So this is a very key concept when you deal with request and response. So let's say you're writing a program, let's say you're sending a video file, right? And then you want to send the content type to a type video. So you can write a program. In the program, you generally set the request header to say I'm not sending a text, I'm sending a video. And then when the server reads it, it's a video, it might use a different method to accept the file, because it expects when it's a video, actually the content size will be higher. So it might change its mechanism to read the data. And in a similar manner, when server try to send the data to Chrome using the content type saying it's a video, the Chrome can change its behavior to say, oh, this could be a large file, so I better download this file, or better I show them right away, right? So content type is really an important topic in HTTP. Let me show you another property of the request that is called as request methods. If you look at the request headers, you can see the first is a general, right? General actually say request method is get, right? So it's actually trying to get something, right? And if you look at the request header parsed, you can see it's also a get method. So request method generally are many types. Request types are used by the requester to tell to provider what it want to do. The first request type is get, that's what we see. Get request type is used by the requester to tell to provider that it want to fetch something from a server. It's like downloading. The header request method is used by the requester to get the header information from the provider. The post request method is used by the requester to post some data to the server. Similarly, put is to store the data at the provider. Delete is to delete the data at the provider. Trace is to request a trace from a provider. Option is sent by the requester to request what options does provider support. And connect generally is used in a proxy scenario wherein you're trying to make an SSL connection. And there are other extension methods. Actually, there are many request methods. The most important ones are get, post, put, delete. So these are the 4 options you will use mostly in your interface development. Let's look at status response code, which actually means when a request is being sent to a server, how the server has processed that request and what happened at the server. Let's take an example. When the request has been sent to a server, the server could be crashed. The server don't know what to do with the request. The server could not find the resource that requester is asking, or the server is just crashed. So in those scenarios, there should be some responses sent back to the requester to tell him what happened, right? And that is the response status code. So if you look at the property here, you see a number called 200, and server is not going to send a big text in a description stating what happened. It uses this shortcode notation to identify or to tell to requester to say this is what happened at the server. And 200 generally indicates it's a success. And if you look at the response header, you can find that 200, which means it's okay, means everything is success. Let's look at all the response code that is been sent over by the provider to the requester. It's a response code, so it's sent as a response by the provider. And you can find this response code as I showed you previously in the Explorer. Previously you have seen the status code 200 as an OK. So I'm just going to list out all the different codes that is been sent from a provider. If the code starts with 1, it actually means the request is received and server is continuing the process. Why server want to send 100 or 101 information back to requester? So it's basically could be a technical act to say I received your message but I'm still processing it. The 200 generally say Okay, I understood your request and this is the output and everything is been served. 3 means it's a redirectional, wherein a further action must be taken in order to complete the request. When you see a status code starting with 4, means it is an error. All the status codes with 400, 401, 403 are error status codes, which could be result into a bad syntax, or the request is not been understood, or the resource is still not there on the provider and then requester is requesting for it. And anything that starts with 500 is basically a server error. It's not the issue with the requester. Requester might ask anything that's available on the server, but server could not provide it because of the server have some internal issue. That's when server will provide a status code starting with 5, which means server failed to serve the request. Port you can think like a small holes to the computer, through which server accepts the data and sends the data. Server provides number representation to each of these ports. You are using HTTP request or response, it will be 80 port. If you are using an HTTPS based request and response, then it will be 443 ports. If you have to imagine server as a bottle of water. Then port are the small holes that you drill through it, through which you can actually extract the water. Similarly, if server accepts HTTP, it will open 80 port. If it accepts secured connection, that is HTTPS connection, it will open a 443 port on its server. So remember these numbers, they are fixed, they are standards, but it can be changed. So whenever someone say I'm connected to an 80 port or can you connect to an 80 port, they are referring to a standard port. And HTTPS generally is a 443. When it's secured, actually the data is encrypted. Even at the client side, even at your system side, you will be sending all your HTTP data via that same port. It's like client will come to a server water bottle and put a glass on the port 80 and request for water, then server will respond with the water. In web, when you type the URL in the browser, your system based on HTTP 480 or HTTPS for 443 will make a connection to the server's IP to that port to request the data. This is visible in the logs on which port the server is responding the data. And any system can change this default port to any other number they want. It could be like 8080 or 8181. I'm just giving you a representation, but the numbers could be anything. How to identify the port? So every server has an IP address, right? So we define a port after the IP address. We put a IP address colon and the port, and that port is not visible when you typed pocast.com because you're not referring to that IP, you're referring to an host name. Host name are generally a virtual name given to an IP. So instead of typing that big numbers, you can just type the host name. And in the background with the protocol, let's say I'm using a protocol called HTTPS, I'm automatically routed to 443 port on that specific server. And let's say you are using a PI or a PO server, you will always use a custom port. You might not be using an IP address and imagine the HTTPS will connect to 443. That's not going to happen. The PO or PI servers will actually have a separate port. So every time you access that URL, you will use the host name or the IP colon the port name to access that port and saying that using this port, try to make a connection and send the data. Well, in case of FTP protocol, it is 21 or 22. Of course, they are standard port, but that can be customized to any number. So remember, from a HTTP context point of view, HTTP is 80 and HTTPS is 443. That's a lot of information being shared. Let me summarize and redefine or just recap what we have learned. So please concentrate. The first, we define protocol. Protocols are a set of rules to communicate. Then we define HTTP. HTTP is protocol used to communicate in web by machines. Then we define two roles. One is requester and another is provider, wherein requester will ask or request, provider will give or response. What's the usage of the HTTP? HTTP protocol helps to establish communication between our web browser and destination server. HTTP request and response will follow a common version, and HTTP request will inform server which one to use. HTTP request format has message header and message body separated with an empty line. Same for HTTP response. HTTP request and response will communicate about the content type they are exchanging. Request will say what it will accept, and provider will say what type of content is sent in the response. And ports are used to exchange the message. HTTP use port 80, HTTPS use port 443, and server or client use port to send data and receive data. HTTP request header will have type of request to indicate what it is trying to do, like requesting something, posting something, want to delete or want to store, etc. The commands used are get, post, delete and put. For more info, refer to the slides. Server send response status back to client indicating in the number format. If the server status start with 1, it actually means informational, 2 means success, status starts with 3, it means redirect, 4 means client error, 5 means server error. Again, refer to the complete list from the slide. Well, good job, you made it to the end. Thank you for spending time to understand this concept. I really appreciate it. Here onwards, when I use these jargons or you read it somewhere, I hope you are not confused. Well, that's the end of this course. If you have any questions regarding the topic I discussed or any clarifications on this topic, please feel free to join the discussion in the forum for this topic, where we can discuss further or to clarify your queries. You can also reach us at support@pocast.com for any kind of questions without hesitation. With that, I will end this podcast and thanks for listening. Have a great day. See you later in next section. Bye. Hello and welcome to the lecture. Let's understand what is client-server technology. So first let's understand what is these words called as client side and the server side. You have to understand these words because we're going to use this language in further sections. We're going to talk about client side, server side, then you should understand what I am talking about. So before that, let's understand what is client side and what is server side. And imagine the situation wherein Jim is basically the buyer and Bob is a seller, and Jim is trying to access Bob's computer via the host name, and then Bob actually have a server where all the files has been stored, all those images, videos and all these files has been stored, and the Jim want to send a request to Bob saying that I want to buy a phone. So in this context, Jim logs in into the web browser, he types bob.com, he send the request to buy the phone. Okay, then the Bob computer accept that request and say, okay, let me send you a response saying that okay, I have a phone available and you can buy for this price. And then the transaction between Jim and Bob happens, and Jim can agree to whatever images he's been showing, and then he can agree to pay the price via the payment method that Bob is offering. And once he pays it, then Bob will transfer that phone to Jim. Okay, so that's basically in this transaction, right? Jim is client side, he is initiating the request. Okay, he is client side, he is the one who is sending the request, and Bob is server side, who is hosting the details and who is responsible is to send the response. So remember, the client side is where the Jim access the browser, and browser is sending a request to the Bob's computer. So Jim becomes the client side, and the Bob's computer, who is hosting all the files, send the response based on the request sent to the Bob. Okay, and Bob is called as server side. There's another name given to him. The client side can also called as requester. Really, he's a requester because he is requesting the details from Bob, right? He is the one logging on to the computer and typing bob.com. So he's a requester, he is client side, and the one that is providing the response is called as provider. Okay, we'll be using this terminology to understand further concepts. We'll be using client side, server side, requester and provider. In this client server technology, there is a requester and there is a provider, and the requester is always requesting the information with the provider, and provider is basically a server sitting in the internet with some files in it, right? And requester is always requesting that information to the provider, and the provider, once it gets those requests, it serves the request by providing a response back to the requester. And all this communication of request and response happening over the protocol called as HTTP protocol. So whenever you see HTTP protocol, so remember that definition. Whenever there is an HTTP protocol, requester is requesting the information and providing is sending that response to the requester. Okay, and all this is happening via an HTTP protocol, which is nothing but an application protocol that is used to transfer data in the web, and that data is nothing but the hypertext. Okay, and we have looked at what is client side. The one who is requesting is called as client side, and one who is providing all those information that is sitting in that server is called as server side. Well, there could be multiple clients and single server. Well, multiple clients like your mobile phone, computer, laptop, all these are trying to access the server and requesting to fetch those details, and server is just accepting those requests and sending the response with all those details back to these clients. Okay, and all this communication happens via the HTTP protocol. Okay, so that's how the client server technology works. Server holds all the information and it is a powerful machine. Most of the times your servers are powerful because server has to handle all the requests from the client. Okay, so it holds all the information, and the job of server is to get the request and send a response. Okay, many clients initiate the request to the server to fetch the data, and then server accepts the request and send the data as a response to that client. Okay, and then client server technology is also called as request response pattern. So if you're hearing request response pattern for the first time, it is embedded in the concept of client server technology. If you understand client server technology, it is nothing but request and response pattern. Client initiate the request and server give the response back to the client. Okay, that's nothing but called as client server technology. So that's all for this lecture, and I'll see you in the next one. Welcome to the lecture on how website works. So let's understand what are the components that makes up a website. Well, we have seen the request and response pattern, that is nothing but the client server technology. The client side, basically a browser, someone will initiate the request, someone will type like phptraining.com. The request is sent to the server, and server will have some files on it, and once it gets the request, it sends a response back to the browser. And whatever the request is requested for, whatever the resources that they have on the servers requested, will be sent from server to the client. Okay, that's nothing but the client server technologies. So let's understand what are the components sitting behind this phptraining.com on the server. On the phptraining.com server, there is something called as web server. Okay, there are different types of web server. We're going to look into types of the web servers that we have. But understand there is a web server who is listening to these requests. Okay, this server is basically saying, okay, this is the request, this is the response, this is the request, this is the response. That's the job of the web server. The web server is always in the listening mode. It is listening for requests, and whatever the request has been sent to him, it will try to execute that. Like if the request is to get a file, then it will execute that command to get the file and send that response via the same web server. And if the request is to execute some language, let's say you have a PHP program, Python program sitting somewhere in the server, and the request is to execute that program, then it will execute that program onto the server, and whatever response comes from that program sent again via the same web server. And your web server typically have database as well. If you're storing the database and you're requesting to fetch the details, then the code that you wrote at your server side will connect to the database, fetch the data, and then it will send back to the web server. Then the web server will send the data back to this client. Okay, similarly, any request that has been done to fetch any of these static files, hypertext files, or media files like images, pictures, will again taken care by the web server. So in this context, so the web hosting comes in picture when you want to have these details. When you have this web server, you want to have some language support, you want to have database files and everything, you buy this from web hosting. Okay, and if you want to have a domain name, that is phptraining.com, you get it from the domain name providers, that is nothing but the GoDaddy and the Namecheap. The web hosting is provided by the HostGator, Bluehost, DigitalOcean, where you get the server and some of the softwares installed on it. Domain name you buy from GoDaddy and the Namecheap, where they sell the domain name, and then you map the domain name with the IP address. Okay, so let's take an example and I'll show you how these things work in real time. So let's do an example and understand how these things work. So this is a server that is sitting in the internet, and I have a public IP address for it. Okay, and on this server, I'm running a web server called as Tomcat, Apache Tomcat, and it is in the listening mode. You see it's blinking, it's listening for request. Okay, the server has been started up. Well, this server is in listening mode. It is listening for request, and whenever the request comes, it will serve that request. So what I'm going to do is I'm going to create a folder. There's a folder called PHP training, and I'm placing an image, I'm placing a video file, then there is something called as an HTML file. Consider this as a file, and what I want to do is I want to fetch these files from the server onto my browser, right? And remember the role of web server. So all the request goes to this web server. This web server will locate the files under its own web apps folder. Okay, it's under Tomcat web apps in the PHP training. So when we try to access, we will provide this name PHP training, and we'll say I want to access these files. Then we'll see from the browser how this Tomcat will get the request and send the response to us, and how the HTTP protocol works in the real time. Okay, we have learned about the client server technology, request and response. We talked about HTTP. All these things we're going to see in the real time. And the challenge that we are trying to understand here is the server is having all these files. Okay, how a client could make a request and fetch all these details from the server. Okay, well, this is nothing called as hypertext, the text file, image file, video file, and then we'll try to initiate a request to fetch those details. Okay, so I'm going to minimize this, and I'm going to open my browser now. Okay, well, this is the IP address where my Tomcat is running, and I have my files, and we have seen the phptraining.com. that is nothing but the folder there, and inside the folder there is a file called index.html. so I'm making a request to my server saying I want to access this index.html file. So when I click enter, so you see the image is been fetched, the video has been fetched. I can play the video, right? I can play the video, means the video is fetched to my client browser, and there is some text that has been displayed onto my browser. Okay, so what is happening in the background, how these things all work together? You are sending a request from your browser to the server, and server has a public IP address. Remember, this has to be accessible from anywhere from the internet, and this is unique. And using this unique IP address, I have a web server running on that server, and on that web server I created a folder called PHP training, and I have some files on it. So I'm trying to say to this server, to the web server, you have a folder called PHP training, can you fetch me this file? And this file actually embeds all those images and videos, and using which it is trying to print those onto my browser. Okay, so let's quickly jump back to our server again. So this is our web server, and we have this doc image. Let me open that up, and then we have this video file. These are called as resources. These are called as the hypertext. Okay, let's go back to our browser. This time we will see HTTP protocol in action. So for that, right click on your browser, go to inspect, or you can say Ctrl+Shift+I. You will come to this window. You can toggle that dock onto your bottom. Then you go to something called as network tab. Okay, so now we will see what is the request that has been sent and what is the response that we're gonna get. Okay, for that you have to refresh the page. So when you refresh the page and when you open up your network tab, you should able to see the files here. Okay, this browser has sent a request to the server, and server has responded with these resources to it. Okay, this is request and response in real time. Right, if you open or click any of this, you go to headers, you will see there is a request URL. So you are sending a request to this URL, and there is a response, and response is nothing but your HTML code. That is nothing but some files, okay, text files. And you can see the files here, right? You get the image, you got your video, you got your files, and this all fetched from the server. Let's do one more time refresh. And refresh basically getting all these files, telling you how much seconds it has taken, milliseconds it has taken to fetch those resources from the server. Okay, so this is how a website works, right? A website is hosted onto a server which has an public IP address, and then you create a folder on it, and then you create some files on it, and using a browser you try to access these files, and this file is basically linking up other resources on the server. So once you request this URL, then the server, that is nothing but the Tomcat server, will get the request and it will respond with all the files that has been requested and send back to the browser. Okay, that's how a website works. So for that website, you see here, I don't have a domain name for it. I can still access my server with the IP address. As I told you, TCP/IP does not require a host name. It works on the IP address. And this is how the HTTP works. This is not TCP/IP protocol. This is an HTTP protocol. So this is an HTTP protocol, hypertext transfer protocol, using which you can send a request to a server and fetch all the hypertext from the server back to your client side. Well, that's all about how a website works, and I'll see you in the next one. Hello and welcome to the lecture. Let's understand type of languages that we have. So we have three different types of languages. First is called as programming languages, scripting languages, and markup languages. You have to understand the difference between them because they have written and implemented differently. And the purpose of each of this language is to solve a different challenges. Okay, so you have to understand this, what you're trying to learn, right? When you're trying to learn a language, whether it is a programming language, scripting language, or a markup language. So the examples of a programming language are like C, C++, and Java. The most important job of a programming language is to interact with the machine. Programs like C, C++, and Java are famous examples of how they can really interact with this machine. So they have this machine level language converted, using which they can really interact with the hardware as well. Okay, that's the power of the programming language. So when you're learning a programming language, you are mostly learning how do you interact with your machines, right? And if you want to write machine level programming, this kind of programming languages will help you do that. Let's look at scripting language. So PHP, JavaScript, Python, and Ruby are scripting language. They are built on top of the programming languages. Okay, they are not the underlying languages. They use like C, C++, or Java or other programming language, and they are built on top of it to solve a specific challenge. Well, PHP is a scripting language that runs on the server. If you want to run a program on the server side, you write PHP. If you want to run a program on the client side, you do JavaScript. Again, Ruby runs on the server side. Python can also be written on the server side. And also Ruby and Python can do many more than just running on the server side. You can write desktop applications as well. But remember that scripting languages actually built on top of any other programming languages. They use some internal libraries and they are built on top of it. So whenever you're working with scripting language, you will find it is easier compared with the programming language because they implement all the complex logic in the behind, and then they give you very easy implementation to write those programs. That's why scripting languages get famous, right? JavaScript, Python, PHP, Ruby, they're all very famous compared to C, C++, because all the complex logic is already pre-written in these languages. And when you try to use them, you're not implementing those complex logic, rather you're using those libraries which has implemented all those complex logic into it. Okay, that's why they are very famous. The other type of language is called as markup language. HTML and XML is markup language. HTML has a different purpose. HTML is used in web to link the resources. We're going to learn about what is HTML and all those things. But remember, HTML and XML are called as markup language because the way they write it, they mark it up all the details inside the file. And when they mark it, they say what they are marking up. They are marking up to link a resource. They are marking up to display a content, or they are marking up to link another file into the server. For this lecture, understand there are three types of languages: programming languages, scripting languages, and markup languages. And you have to understand the differences between this three of it. Well, programming languages are mostly used as compilers. So we're going to look at what is compiler and interpreter next. But understand, programming languages uses compiler to compile the code, and scripting languages are interpreter. They don't need to compile it, they run as it is. So we're going to see an example how this works in the real time. And the next section will be to understand compiler and interpreter. Okay, so that's all for this lecture of different types of languages that we have. Let's look at compiler versus the interpreter. Hello and welcome to the lecture. Let's understand what is the difference between compiler versus interpreter. So we have looked at different languages: programming language, scripting language, and markup language. And we have also discussed programming language uses compiler like C, C++, and Java. And scripting language use interpreter like PHP language, JavaScript, Python, and Ruby. So what is the real difference between compiler and an interpreter? Let's understand this. Well, in the compiler based languages, you write your code, then you compile your code. And once you compile the code, you get another machine level code, which you basically execute it. Okay. So there is this two part that you have to do. Whenever you write a code, you have to compile it and you have to run the compiled code. That's the programming languages like C, C++, and Java, where you write the code, but you cannot execute that code. You have to compile it first. Then once you compile, you get something called as machine level code, and then you execute that machine level code. Okay. So let's look at an example. Let's understand how to compile a Java program. Okay. So I have this Java program. Let's open this up, open with Notepad. Okay. Very simple Java program to print hello world, right? But you cannot execute this code. Okay. You have to compile this. When you compile, you get something called as machine level code, and then you execute that code. So let's run this program. So before you run this program in the programming languages, you have to compile this. When you compile, you will get something called as machine level language. So when you compile, observe there's a file create, and you can only run that file. Okay. So let's compile the program. And when you compile the program, it will create something called as class file. So let's open this file. Okay. You cannot understand this program, right? Because this is machine level language. Okay. So let's run this. Okay. So you're able to print it now. So this is basically a compiler. You compile your code, then the file is created, compiled file is created, which is executed. Then you execute the compiled code, which is understood by your machine. So in programming languages, you have to compile the program. That is the first step. And then you have to run the compiled code. Okay. And the compiled code is not really in English. It will be in the machine language. Okay. And that's understood by the Java only. And then Java can run the compiled code, but it cannot execute the Java program, right? It cannot understand what is this English program that you have written. You have to compile that first, right? Once you compile, then only you can run that file. Okay. There's a two-step process in compiler. Okay. Let's understand interpreter. So let's understand what is interpreter. So I have PHP basically is a scripting language, and it is an interpreter. So if you open any PHP file, okay, it has hello world. In order to execute PHP, you don't have to compile this. So if you go to this folder, okay, you have one.php. You don't have to compile it first, but you can really execute as it is. You can see I did not compile it. There's no compiled code here as well. Okay, this is called as interpreter, where it is in interpreter you don't have to compile it. It interprets as it is running the file. Okay, so that's the difference between compiler and an interpreter. Well, that's the difference between a compiler, wherein you write the program, compile it, and run it. In interpreter, you don't have to compile it. You just write it and then run it. And PHP is a scripting language that use interpreter. Java is a programming language which use compiler. Okay, so that's the difference between compiler and interpreter, and I'll see you in the next one. Hello and welcome to the lecture. Let's do the recap on what we have learned in this section. Well, we looked at what is protocol. Protocol is nothing but set of rules that two devices agree before they start communicating, right? Any two devices want to talk to each other, they agree onto a protocol. That's what we learned about protocols. Then we understood about what is internet. Well, internet is a network where group of computers connected together with a single wire to exchange information. Then we talked about TCP/IP protocol. TCP/IP protocol is used to exchange data packets between the system. Then we talked about domain name service. Well, domain name service is used to map host name with the IP address. Then we talked about HTTP. Well, HTTP stands for Hypertext Transfer Protocol, using which we can exchange pictures, videos, and files over the web, and this kind of data is called as hypertext. Then we talked about client-server technology. In client-server technology, client makes a request for a resource in the server, and a server sends a response by sending that resource to the client. Then we talked about how to host your own web service. Well, to host your own web service, you need to purchase a domain name and a space from web hosting to publish your website. Then on the domain name service, you basically map your hosting services. Then we talked about differences of different types of languages, and also we talked about what is compiler and an interpreter. Compiler is used to compile the code into machine level code. Interpreter runs the code at the execution times. These are the things I want you to remember and take away from this section. Hello and welcome to the section summary. Let's do a quick summary of what you should be able to learn by now. So by now you should be able to understand terms like protocol, HTTP, internet, TCP, IP and DNS. Make sure when someone asks you any of this definition, give your own definition of how these things work. Then you should know what are DNS providers and web hosting providers in the market. And you should understand what is a client server technology, how typically a website works, and what are the components of website that basically makes the website works. Like what is the type of the web servers that you have. Then you should understand the difference between programming language, scripting language and the markup language. If you have decided to learn any of the languages, you should know in which category it falls and why are you learning it. Then you should also know what is the difference between a compiler and an interpreter. Okay, so that's all this lectures on this section on web basics, and I'll see you in the next one.